Hello everyone. On this video we will be covering what is known as Newton's method. Okay, so for Newton's method, what we're going to do is we'll be using the tangent lines to find the zeros of a function. Okay, at least the approximation. To a certain number of decimal points. Alright, so to start, you're going to have to remember the intermediate value theorem. Okay, so what that says is that there's at least one zero on the interval from A to B if these conditions are met. Okay, condition number one, it's continuous on that interval. Let me clean up that S a little bit. There we go. Okay, so it's continuous between x equals A and x equals B. Condition number two, it's differentiable between x equals A and x equals B. Alright. And third, if f of A and f of B have different signs. Alright. So, just to kind of help you visualize it, we kind of screw that up a little bit. Okay, so let's say we have our interval. This is our x-axis, this is our y-axis, and we're going from A to B. And let's say this is our graph here. So our graph looks something like that. Bring that down a little bit. Okay, so above our A-axis on the graph, and for our B-axis, we're going to go down to that point there. That means this point, that's our f of A, and this point is our f of B. Okay, this is our A f of A, and this is our B f of B. Those are 2 points on the graph. Okay, so what if we wanted to find what value of C between A and B would give us f of 0? Well, f of x equals 0. Okay, so what if we picked some x number 1? Okay, we don't know what that value is. We know it's between A and B. Okay, so at that point, we know that the slope is right there. Looks something like that. Okay, so it gives us an estimate. Because that slope, if it keeps going down and down and down, is going to cross at some point that we will call x number 2. Alright, so at that point, x number 2, let's say we find that on the graph, and we find that slope. And that slope, you forgive my drawing, there, that slope will eventually cross the x-axis, and we'll call x number 3. And what we'll do is we'll just keep using those slopes over and over and over until we get closer and closer and closer and closer to the c value that actually crosses the x-axis. And that's our c value that equals 0. So a lot of times what they'll want you to do is they'll just want you to approximate it. Okay, so instead of going over and over and over and over, because Newton's method can be kind of time consuming, they'll just say, okay, go up 2 cycles or something like that, or 3 cycles of Newton's method. Okay, so you don't have to do this 20 times to get the exact value. Okay, so sometimes they just want an approximation. Hence the approximately in our description. Okay, now this repeated process is called Newton's method. This repeated process is called Newton's method. We'll move that up some. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and jump to our explanation of what Newton's method is and how to use it. Okay, so believe it or not, we're going to start with the definition of, or the formula to find a slope. So your slope is equal to y minus y1 over x minus x1. Okay, that's when you know what your one point, your x1 and y1 is, but you don't know a second point. Okay, so if you remember, this actually is the lead into finding the point slope form, but we're using it here also. Okay, so what if we multiply both sides by x minus x1? Okay, so that leaves you with y minus y1 is equal to m times x minus x1. Okay, now if you remember, little sub note here, y is equal to f of x. So that means your y is equal to f of x, so your y number 1 is equal to f of x1. All right. And also, if you remember, I'm going to make a little, your slope is equal to f of x1. So your slope at x number 1 is f prime of x1. Okay, so we get all of that, and we start replacing things in this formula up here. So you have y minus y1. Actually, what we'll do is we'll first solve for y. So we'll add y1 to both sides. So y is equal to y1 plus m times x minus x1. Now y is equal to f of x, so we'll make that f of x. y1, remember that's f of x1, plus your slope, remember your slope at a point is f prime at that x1, so f prime of x1 times x minus x1. All right, so right now it's not too bad, we're just kind of replacing things. Okay, so what we'll do next is we're going to distribute that derivative or that slope. Okay, now note one thing. We are looking for the 0. Remember, that's the whole point. Find the zeros of a function. Okay, so how do we find the zeros? Easy, f of x equals 0. In other words, f of x equals 0. So we'll make that f of x equal 0. So that equals f of x1 plus, and if we distribute that f prime of x1, we have f prime of x1 times x minus f prime of x1 times x1. Okay. So what we're going to do here is we're going to solve for x. Okay, so if we add f prime of x1 times x1 to both sides, we have f prime of x1 times x1, and we subtract f of x1 to both sides, minus f of x1, that equals f prime of x1 all over x. Okay, so now we just go ahead and divide all three terms by f prime of x1. Alright, so you see here, the f primes cancel out here, and they cancel out here. So you end up with x equals x1, because that x1 is by itself, minus f of x1 all over f prime of x1. And actually this will now become your x2, because that's how you find the next x value. Okay. Now if we go through all of this again, just instead of x1 we now use x2, we'll end up with x3 equals x2 minus f of x2 over f prime of x2. Okay, and that keeps going and going and going and going and going as many times as necessary or as you like. So we end up with x of n plus 1 is equal to x sub n minus f of x sub n all over f prime of x sub n. Okay, so you notice here, it just keeps going. You have your 1 here and everything else is x sub 2. You have your 2 here and all of those are x number 1s. So that's where that formula comes from. So this is your Newton's method formula. Let me clean up that S. There we go. Alright. So if you are still writing, feel free to press pause. But we're going to go ahead and jump to our first example. Alright. So, for example, let's say when Newton's method is used to approximate the root of f of x equals x to the third minus 2x squared minus 3x minus 2 in the interval from x equals 3 to x equals 4, what is the x number 2, or they may say what is the second iteration rounded to the nearest hundredths? I'm out of room for my question mark. And clean that up. There. There's 100. Okay. We use x sub 0 equals 4 and round up to the nearest hundredth on each step. Okay. Now I know this probably looks like a really complicated problem, but it's not that bad. Okay. And I'll show you why it's not that bad. It takes a little practice, but once you get it down, it's not that bad. Okay. So the first thing you have to do is remember we're using Newton's method. So x sub n plus 1 equals x sub n equals f of x sub n over f prime of x sub n. Okay. This is your Newton's method formula. Okay. So the first thing you have to do is find your f of x sub n and f prime of x sub n. Okay. Your f of x sub n is easy. You just replace every x with x sub n. Okay, so your first step, find f of x sub n and f prime of x sub n. Okay, so we know our f of x sub n is just going to be x sub n to the third power minus 2x sub n squared minus 3x sub n minus 2. And your f prime of x sub n is just the derivative of that. So you have 3x sub n squared, 3x sub n squared, minus, bring that down, 4x sub n minus 3. Okay, so it's the same function and derivative. The only difference is your x is now x sub n. That's the only difference for your first step. Okay, now your second step, you have your initial x value, your x sub 0. Okay, so given that x sub 0 equals 4, find x sub 1. Okay, and to do that, you make your n in your Newton's formula equal 0. Make n equal 0. Okay, so if n is equal to 0, 0 plus 1 is x sub 1. So x sub 1 is equal to x sub 0. That should be minus. I'm glad I caught that. There we go. Sorry about that. X sub 0 minus f of x sub 0 all over f prime of x sub 0. Okay, so all we did was use Newton's method, but we made our n equal 0 to find where the n is equal to 1. Okay, so if we fill in everything, that means x sub 1 is equal to x sub 0. We already know that that's 4. Well, you wrote it down here too. That's 4. Minus f of x sub 0, which is f of 4, all over f prime of 4. All right. So now all we have to do is replace our x sub n with 4. Okay, so all of those get replaced with 4. So you end up with, let me bring that underneath just to make sure I have enough room. Okay, so that's x sub 1 equals 4 minus f of 4. Remember that's going to be 4 to the third minus 2 times 4 squared minus 3 times 4 minus 2 all over f prime of 4, which is 3 times 4 squared minus 4 times 4 minus 3. Okay, so if you go ahead and calculate all of this, you see your x sub 1 rounded to the nearest hundredths will be 3.38. All right, so that's one iteration. Now for your third step, you're going to do your second iteration. Okay, so here we have our x sub 0, we have our x sub 1. So now for your third step, you do everything you did here, but instead of using x sub 0, we're going to use our x sub 1. Okay, so given that x sub 1 equals 3.38, find x sub 2. And this time you just make n equal 1 in our Newton's method formula. Okay, so if we make n equals 1, you have x sub 1 plus 1, so x sub 2 equals x sub 1 minus f of x sub 1 over f prime of x sub 1. Okay, so we're using the very same formula, we're just changing our independent variable. Okay, so that means we have x sub 2 is equal to x sub 1 minus f of x sub 1 all over f prime of x sub 1. Okay, so you see the subtle similarities in these two. Okay, everything just goes up 1. This changes to 2, these change to 1. All of those sub values change to 1, go up 1. Okay, so that means if we keep on going, our x sub 2 is equal to our x sub 1, 3.38, minus f of x sub 1, so that's f of 3.38 over f prime of 3.38. All right, so if we plug all of that in, let me move this over just a little bit because it may get a little lengthy. Our x sub 2 is going to equal 3.38 minus f of 3.38, so that's just replacing all of our x values with 3.38. So that's 3.38 to the third, 3.38 to the third, minus 2 times 3.38 squared, minus 3 times 3.38 minus 2, all over f prime 3.38. So we just replace everything in our f prime with 3.38, where all the x is, with 3.38. They have 3 times 3.38 squared minus 4 times 3.38 minus 3. Okay, so once you plug all of that into your calculator, or if you're really fancy, you can solve all that by hand, but you'll be a minute. But once you plug all that into your calculator, your x sub 2 is rounded to 3.18. Okay, so this is your second iteration. Okay, now if you want to get closer and closer and closer to your actual 0, you just keep going and keep going and keep going using the same process to find x3, x4, x5, and you'll get closer and closer and closer and closer and closer to the 0 of your f of x. So here, let me bring that back up. All right, so if you are still writing, feel free to press pause But we're going to go ahead and move on to another example. All right. So for this example, let's say using Newton's method, to approximate the root. Oh, just a heads up, when they say approximate the root, that's just another way of saying approximate the zero. Okay, so it doesn't mean the square root or anything like that. It just means approximate the zero. So when they say the root, that's another way of saying the zero. So you may see it either way. Of, let's say, f of x equals 3x to the third minus x squared minus 8x in the interval from x equals -2 to x equals -1. Using, here we go. What is our second iteration? Rounded to the nearest hundred. Let me clean up that G a little bit. Here we go. Okay, now we're going to use x of 0 equals -1, and we're going to round each step to the nearest hundred. All right. So, starting off, again, I'm just going to write down your Newton's method equation. X of n plus 1 equals x of n minus f of x of n all over f prime of x sub n. Newton's method. All right. So if you remember your first step, find your f of x sub n and f prime of x sub n. So find f of x sub n and f prime of x sub n. Okay, which is not extremely difficult for our f of x sub n, just replacing all the x's. That little eraser bit out the way. Okay, so f of x sub n is equal to 3x sub n to the third power minus x sub n squared minus 8x sub n. Okay, and your f prime of x sub n, move that up a little bit. Bring down that 3, so that's 9x sub n squared minus 2x sub n minus 8. Okay, that brings us to our second step. Okay, so we know where we're going to start. That's our x sub 0 equals -1. So if we're given x sub 0 equals -1, we want to find x sub 1. Okay, and in our Newton formula, that just means that your n will equal 0. So you'll notice each time you go up, n will equal 0. Then on the next one, n will equal 1. Then on the next one, n will equal 2. Then on the next one, n will equal 3. It all depends on how many times you're going to actually use that, or how many iterations you need for your specific answer. All right, so let's go ahead and toss that in there. We make n equals 0. that gives us x sub 1 equals x sub 0 minus f of x sub 0 all over f prime x sub 0. Alright, so that means our x sub 1 is going to equal x sub 0, which is negative 1. So you have negative 1 minus f of negative 1 all over f prime of negative 1. Alright, I'll move that over just a smidgen. So our x sub 1 is going to equal negative 1 minus f of negative 1 is just 3 times negative 1 cubed minus 3 squared minus 8 times 3 all over f prime of negative 1, which is 9 times negative 1 squared. There we go. Minus 2 times negative 1 minus 8. Okay, so once you plug all that into your calculator, you end up with x sub 1 is about negative 2.33. And that's rounded. Alright, so now we go on to our third step and do our second iteration. Okay, so once again, given that x sub 1 is equal to negative 2.33, we want to find x sub 2. But in this case, we're going to make our n equal 1. So we want to find x3, we make n equal 2. We want to find x4, we make n equals 3. So you can see how it's kind of going that way. Okay, so using the exact same formula, you have x sub 2 equals x sub 1 minus f of x sub 1 over f prime of x sub 1. Excuse me. Alright, so if we go ahead and start replacing stuff, we have our x sub 1. So we have negative 2.33 minus f of negative 2.33 over f prime of negative 2.33. Alright, so again, just going to move that over because this part's going to stretch out a little bit. So x sub 2 is equal to negative 2.33 minus f of negative 2.33. So that's going to be 3 times negative 2.33 to the third. So let me clean up that 3. 3 times negative 2.33 to the third power minus negative 2.33 squared minus 8 times negative 2.33. I'm looking up there. I was really close to saying negative 8 times x, but negative 8 times negative 2.33. Okay, all over your f prime of negative 2.33. So that's 9 times negative 2.33 squared minus 2 times negative 2.33 minus 8. And I think I caught, well, the answer is the same because I did it before recording, but for some odd reason, I was supposed to put negative 1 there. I'm pretty sure some of you were going, you wrote in the wrong number. Okay, I wrote in the wrong number there. So, but a mistake is only horrible if you don't catch it. So, caught that one just so happens for some odd reason. Must have been thinking of something else. But that should have been negative 1 there. Again, the answer is right because I did it beforehand. But those two should have been negative 1. So, my mistake. I apologize on that one. but we caught it. Alright. So, what that gives us, once you put all of that into the calculator, and like I said, if you're really feeling fancy, you can do that in your, by hand, but if you put all that into a calculator, your x number 2 is approximately negative 1.79. Again, that's your rounded answer. Alright. So, if you are still writing, feel free to press pause, but we're going to go ahead and move on to our last example. Put my little end of the problem square. Alright, so this one we're going to kind of switch it up a little bit. Say using Newton's method, to approximate square root of 50, use 8 as your initial value and round to the nearest hundredth. Alright, now I'll give you a hint. And this will come in handy when approximating square roots. Start with a function of degree 2. Alright, so we're going to go ahead and solve this one. Okay, so what do we know? Well, using that, we're going to look for the 0 of that one. So we know using Newton's method, there's going to be some value that's going to be 0. Because remember, that we use Newton's method to find the zeros. That's what we're known for. Alright, so since we're looking for the square root, what if we let f of x equals x squared minus 50? Okay, now why do we do that? Well, we're looking for the square root of 50, but we also know that the square root of 50 squared is equal to 50. Alright, so using our same approach that we used before, we have our f of x sub n, which is x sub n squared minus 50, and our f prime of x sub n, which is 2x sub n, and that 50 just turns into 0 because the derivative of a constant is always going to be 0. Alright, so we have the same first step here. Alright, so for our second step, given that our x of 0 equals 8, because remember, that's what they gave us. We want to find our x of 1. Again, that's when you make n equals 0. Alright, Oh, forgot to write the Newton's method, but I'll write it over here. X of n plus 1 equals x of n minus f of x of n all over f prime of x of n. Okay, that's our Newton's method formula. All right, so we go ahead and find our x of 1 when n is equal to 0. So that, move that up a little bit. X of 1 is equal to x of 0 minus f of x sub 0 over f prime of x sub 0. Okay, so it means your x of 1 will equal 8 minus f of 8 all over f prime of 8. Okay, so our x of 1 will equal 8 minus f of 8. Remember, your f of 8 is just going to be 8 squared minus 50. 8 squared minus 50 all over f prime of 8, which is just 2 times 8. Okay, so that means your x of 1 is approximately 7.13. Okay, so now we go to our third step and find our x of 2. Okay, so given that x of 1 is equal to 7.13, find x of 2. And remember, that's when n is equal to 1. We kind of separate that a little bit. All right. So now we do the exact same thing with the exact same formula. So we know that our x of 2 is equal to x sub 1 minus f of x sub 1 all over f prime of x sub 1. All right, so that means our x2 is going to equal our x1, which is 7.13. Minus f of 7.13 all over f prime of 7.13. All right. So our x sub 2 is going to equal 7.13 minus f of 7.13 is just 7.13 squared minus 50. 7.13 squared minus 50 over 2 times 7.13. 2 times 7.13. Okay, so when you plug all of that into your calculator, that's going to equal 7.07 once you round it. Okay, so using the Newton's method, that would be your answer. All right, so hopefully this made a little bit of sense, and I will see you on the next video.